All right, we're going to go ahead and get started. So I'm going to share my screen with you. Let's see if I could do that. Let's see, share my screen. Okay, so everybody can see my screen okay? All right. So I'm just really quickly going to go through the agenda for today. And since you guys are already here, you're in the meeting, you don't need to do some of this. Like, so for instance, we're going to be doing part of this together where we're talking about what we got in the lab. But number 3 here, it says for those people unable to attend the meeting, they're going to have to watch a video of what I'm recording right here. And they're going to have to do this attendance SWIC, and they have to get a perfect score. Since you're here, you don't need to do that. You're going to know what the answers are. The code, they're going to need an access code, and I'm going to give the access code here during the meeting. If you want to write it down to do the quiz yourself, you can, but you don't need to because you guys are actually here. So I'm going to go ahead and give the first 3 digits in this 9-digit code. Again, since you are here in the meeting, you don't need to do this, but for the people who aren't able to attend, they're going to have to record this. So the first three digits are the number 4, lowercase a, lowercase f, and I'll give the rest later. Okay, so what we're going to do first is we're going to share our lab observations. First of all, I need to talk about, if you remember, whenever we do a lab, I always afterwards, we whiteboard it, and then afterwards I give you a sheet of paper where you basically just copy all the answers and you turn it in. Well, we're going to do something similar to that, but you can't turn it into me in a piece of paper. So where that lab is right here. You'll click on this link, and you'll do this later. Don't do this now. And what you're going to do is you're going to come up here and make a copy of this yourself, and you'll come in here and you'll type your name in, you'll type in the purpose, you'll either sketch the graphs or you will just simply go to your data, copy and paste it on here, whatever you prefer. Okay, so let me get rid of that. So anyway, I think what we're going to do is we're first going to share off kind of what we found for this lab. If you remember what this was, is you had this person, it was kind of looked like a digital thing, but this person was pulling on this car and made the thing get faster and faster by either changing the mass or changing the force or whatever. Oops, wait a second. I gotta let Jacob in. I'm not sure how I do that. Sorry. There we go. Okay, so I kind of want to look at the data that everybody got. And for the first part of the lab, these are the people who sent me data that was done correctly. If they didn't do it correctly, I sent an email back to them saying, hey, you really ought to redo that. So we're going to look at Josh, who's here, I believe. David's, Jasmine's here, Noah's here, Brenna's here. Josh Rodriguez is, I don't think he's here, but got his data. Kari, I don't think he's here, but I have his data. And Johnny, I have yours. So these were all done correctly, and I kind of want to show you what these people got for the lab. So let's see if I can find it. I got another person wants in. How do I let people in without getting out of here? Sorry, I'm trying to figure out how to let people in without minimizing each time, and I can't figure out how to do that. Okay. Okay, so I want to look at the data that some people had. This is part one, and let me move this over. This is Josh Brown's, and I want you to look at this. This is what his graph looked like. So it kind of looks just like a normal line there. Um, Again, I need somebody else is trying to get in. I'm sorry. I think I'm going to have to say that if people come late, you're just going to have to watch the video. Sorry. I don't have time to keep on exiting out and entering, letting people enter. It's not really respectful of the people who are here on time. Okay, and then let's look at the next person. So notice it kind of looks like it looks like a line, linear relationship. This is David's, also kind of look like a line. This is Jasmine's, kind of look like a line. This is Noah's. Get it to show here. His also kind of look like a line. This is Brenna's. My computer's low. There we go. Oops, let me move over here. Also kind of look like a line. This is Josh's. Josh Rodriguez. It looks like a line. This is Kari's. Kind of looks like a line. And this is Johnny's, I believe. It also looks like a line. So in other words, it looks like for this first part, when we're looking at the acceleration versus the force, it looks like it's a direct relationship. So let me go ahead and minimize this. So in your lab, you would first of all have to put the purpose. So you type in the purpose to graphically and mathematically model relationships between the acceleration of the cart and the unbalanced force on the cart and the mass on the cart. If you're like, I don't remember where that's at, do I have to watch this video again? No, it's also right here, learning target. So that's right there. Now for the relationship, it looked to me like the consensus was it was a linear relationship. So you could either sketch on here that nice direct relationship, or you could go ahead and go to your data and just simply take a snapshot and paste it on here. Okay, so now I want to go ahead and look at the relationships people found for the other part of the lab. So versus mass. So this is, again, Josh Brown's. Kind of looks like, we call that an inverse relationship. This is Jasmine's. Looks like an inverse relationship. This is Noah's. Looks like an inverse. This is Amani's. Looks like an inverse. This is David's. Looks like an inverse. Carson's. Kind of looks like an inverse. He put exponential, but I think it actually would have been better as an inverse. This is Brenna's inverse, Kari's inverse, Josh Rodriguez looks like an inverse, and I don't remember who this one was. Let's see. Part two. Oh, that was Kylie's. Kind of looks like an inverse. Okay. So it looks to me like the consensus is, for the people who gathered data correctly, kind of looked like it was an inverse relationship. So again, you could either sketch it, or you could just simply copy and paste it. Yeah, that's not very good. Let's see if I can do a better job. So there's my sketch, or if you want to copy and paste it, make sure that you put the title down. Notice I've got all these things in here. I've got the title up here. Make sure you have that. Make sure you have the labels on the axes, or this axis down here. So make sure you have all that. Same thing for the other graph, okay? Okay, so then the mathematical models. Let's go back over the mathematical models for each of the different groups. I can't see stuff. Sorry. No, okay. So, oops, I messed something up. Sorry. All right, so the mathematical model, let's go back to the first part. The mathematical model, this was Johnny's. His mathematical model looks like y equals mx plus b. For Kari's, y equals mx plus b. Josh's, y equals mx plus b. This is Brenna's. She has y equals 0.66x plus a negative, again, that's y equals mx plus b. This is Noah's, same thing, y equals mx plus b. Jasmine's, same thing. David's, same thing. And Josh Brown's, the same thing. So that means for our mathematical model, for this first graph here, I'm going to put it right underneath here. I'm going to scroll up a little bit. Oops. All right, let me see if I can figure out how to move this thing. Put it up here. For this first graph right here, I'm not going to put y equals mx plus b. Well, at first I will. How's that? Y equals mx plus b. But I need to put in what the y-axis really is. The y-axis really is acceleration. So I'm going to use the letter A. Instead of m, you need to put your actual number in. So whatever your slope was. So I'm going to say slope. I'm going to call it slope 1. For instance, if I were, let's see, Josh Brown, your slope, it looks like, if I'm looking at this correctly, it looks like your slope is, I think it's 1.724. So if I was Josh Brown, I would put in for my graph right here, I'd put in my slope to be 1.724. We also need units, and the units would be meters per second divided by newtons. All of these were a direct relationship, which means we can drop off the b, the y-intercept, and the x would be equal to the net force, F net. So everybody's equation is going to look very similar. It's going to be A equals some slope, some number, right? Some slope. And then it's going to be meters per second over newtons times F net. If I was Josh, the number I put in for slope would be that 1.72 whatever. If I were, let's say Jasmine, I would say the slope she would put in would be 2.267. 2.267. So we all have the exact same equation, except we'll have a different number here for the slope. Any questions about that? Okay, all right. All right, so then for the next one, the acceleration versus the mass, we have to get the mathematical model for that too. So let me look at everybody's relationship here. So let's start off, I think this was Kylie's, if I remember right. It looks like, it's hard for me to read this number here, but I think it might be 0.7131 over x. For Josh R, his is, oh, maybe it's not 0.7, maybe it's 7.1. Sorry. For Josh, it's 4.402 over x. For Kari, it's 1.522 over x. Brenna, it's, again, it's kind of hard for me to see. I think it's 5.057 over x. Carson, well, Carson used an exponential. He really should have used an inverse. So Carson needs to go back and do that part again. For David, it looks like it's 4.004 over x. Amani, it's 5.694 over x. This is Noah's. It's kind of hard for me to see. I think it's 2.369 over x. And Jasmine, it's 4.997 over x. And for Josh Brown, it's 4.886 over x. Okay, so that means we all kind of agree on the mathematical model for this one too. So I have to write another mathematical model. Oops, sorry about that. So for this one, it's going to be acceleration equals some number. I'm going to say slope 2 divided by x, but don't put an x. X really is, in this case, x is this axis right here, it's mass. So it's over m. We also need to have units for slope 2. So for instance, the units would be, let's see, it'd be meters per second divided by 1 over kilograms. If you're like, why is it 1 over kilograms? It's because this is an inverse relationship, okay? So that's kind of a messy looking unit. It's kind of ugly. It's meters per second over 1 over kilograms. If I were, for instance, let's say Josh, instead of saying slope 2, I'd have 4.886. So right here for slope 2, I'd put in 4.886. 4.886. Or if I was, let's say Noah, I would put in 2.369. Or for instance, if I was Jasmine, I'd put in 4.997. Okay, so I'm going to go back though, and I'm going to call this slope 2. Okay. So those are your two mathematical models. Except don't put slope 1 and slope 2. Actually put in what your numbers were from your lab. Okay. By the way, if I didn't show your graph and you're like, well, wait a second, why didn't he show me my graph for part 1 or my graph for part 2? Well, it's because your data at the time wasn't correct, and that's why I sent you an email back that said, hey, you need to redo that part of the lab. If you're like, oh, I don't know what's going on, I can help you. I can do one of these conferences with you one-on-one. Nobody else has to be there, and I can help you get the data and get it correct. Okay, so just send me an email. We can do that some other time. All right, the consensus model. What we're going to have to do is we're going to have to combine these together. So let me help you do that. Notice on the left-hand side for both of these equations, I'm going to have this one. Let's see if I can do that one in a different color. Let's make that color red. Can I do that? So here's this equation. Let's make this one here, I don't know. Let's make it, how about blue? Okay, I need to combine that red equation and that blue equation together. Notice on the left-hand side of both the equations, you have A. So it's going to be A equals. Okay, now this is a little bit tougher. On the right-hand side, I see that it's directly proportional to the net force, that's the red, and it's inversely proportional to the mass, so over m. So what we get is the following. We get F net divided by m. That's the equation, okay? That's the combined consensus model. Now, I don't know about you. I don't like fractions. I think they're a little bit tougher. So let's rearrange this equation so there's no fraction here. In other words, see how it says divided by m? I can multiply both sides by m to get rid of that in a denominator. And if I do that, I get m times a equals F net. I'm going to write this slightly different. I'm going to say F net equals m times a. It's the same thing, right? Doesn't matter which order I do it in. So either one of these equations you can put down. You don't have to put both. So when you're turning in your own lab, you can either put A equals F net over M, or you can have F net equals M times A. Okay, so we're going to use that equation to solve some problems here. Okay, before I do that, I need to give you the other 3 letters of that code for the attendance wick. So I've given you 3 letters already. Okay, there's 9 altogether. Here's the next 3. These are all lowercase letters. V as in very, B as in boy, and W as in whale. Okay, so we're going to use this equation, F net equals MA, to solve these problems, 27, 28, and 29. Then we're all done, okay? So we need to find what the net force is on this object. It says we have a 2 kilogram object and it's accelerating at 3 meters per second. Okay, so we're trying to find the net force. So the net force would be equal to the mass, which in this case the mass is 2, times the acceleration. The acceleration is 3. So how about you guys do this one? What do you get for the net force? Can somebody talk? You might unmute yourself.
6.
Yeah, you get 6. That's the answer, 6 newtons. So the answer for this one is 6 newtons. Don't just put the answer down. Please show this work. Okay. All right, so the next one, number 28. Any questions on 27? Okay. Number 28. 5 kilograms is added to this object up here. Assume that the net force is the same. So we just found the net force is 6. Calculate the new acceleration. All right, so we're going to start off with F net equals MA. We just found the net force was 6, and that's equal to MA. Well, the mass is not just going to be 5, it's going to be 5 plus the 2. So it's really going to be 7. So the total mass is 7 times A. Okay, so how about you guys grab a calculator, and I'll grab a calculator too, and solve for acceleration. I'll give you a hint, you get a decimal. It's less than 1. Anybody get an answer? You could just round it to, let's say, the tenths or hundredths or something like that.
0.85.
That's it. Yep. I got, actually I got 0.86, but yeah, that's good enough. 0.86. And the units are meters per second per second. Okay, the last one. Oops, what the heck? All right, sorry about that. There we go, it's better. It says now the mass is removed from the object, so evidently it must be 2 kilograms again. Oh, wait, no, maybe not. It says calculate the new mass. So we just know there's some mass taken off the object. And it says its new acceleration is 5 meters per second squared. Assume the net force is constant. Excuse me. Calculate the new mass. All right, so again, we're going to use F net equals MA. And it says what the acceleration is. We found the net force up above in number 27. So the net force is 6. So it's going to be 6 equals m. We don't know what m is, times the acceleration. They just told us it's 5. So why don't you take a calculator again and solve for the mass. I get a number bigger than 1, slightly bigger. So why don't you go ahead and calculate it. Anybody get an answer?
$1.2.
That's it. 1.2 kilograms. That's the answer. 1.2 kilograms. Okay, so again, I want to explain what you're doing then. For the people who came in late, you're probably going to have to take that quiz. Oh, I need to give you the last 3 digits. Sorry. So the last 3 digits are lowercase letter E as an elephant, the hashtag symbol, it's the pound symbol, it's right above the number 3 there, and the number 6. So the last 3 digits are lowercase e, hashtag, the number 6. So altogether there's 9 digits there. And so then you can take this attendance quiz, which is kind of over what we talked about today. So what you're doing for homework though is here number 2, you're clicking on this link, you're going to make a copy of this lab, and you're going to be typing in or copying and pasting in your answers here, okay? And once you have that done, that's your lab, then you're going to make or you're going to share that with me, send me an email or something, and that's your lab. That's it. Any questions? By the way, let me pull this back up here again. So if you see, this is part 1. If you say your name on here, then that means you did that lab correctly and you shared it with me, and so I know it's right, okay? And so you're good to go. If your name's not up here, then that means I didn't get it from you last week, which is also a problem, but or maybe you shared it with me, but it wasn't correct and you needed to fix it. If you need to fix it, I'm here for you. I can help you. I can meet with you in one of these meetings, just you and I individually. I can help you get correct data. For part 2, again, if you don't see your name here, then that means I didn't get the correct data from you, and either you need to do it again or you didn't share it with me. Again, I can help you if you need help. You can see that this lab is going to be worth quite a bit of points. It's not just going to be, oops, sorry, I clicked on the wrong thing. It's not going to be just filling this out, right? Because I kind of did that for you in a way. It's also going to be, if you shared that data with me, it's going to be an extra 10 points, 5 points for the acceleration versus net force and 5 points for the mass. So the people whose name's on here, you've already shared it, you're good to go. And if you have your name on both lists, then you got your full 10 points. If you didn't get your name on both lists, you should send me an email so I could look at it and let you know if it's right or wrong. And if it's wrong, then you and I can get together. I'd be glad to help you out. All right, so any questions before I let you go? Okay, so that's it then. Hope you have a good day. Hope you stay safe, and I hope this ends pretty soon. See ya.
Bye.
Bye.